What do air disinfection lights, a home heat pump, an industrial PLC, stage lighting, and a local voice assistant have in common? Almost nothing, until each one needs to move data beyond its own enclosure. This is not a roundup of Ethernet chips. It is a look at 5 things people actually built, and the exact boundary where local control meets the rest of the system. In every case, the application makes its own decision. The network carries the result, the status, or the command. Airflow rises. The controller brings more disinfection light banks online. This Arduino application reads a 4 to 20 milliamp air velocity sensor and a radiometer. A pathogen signal can override the normal level. 3 relay outputs control the disinfection light sets, while runtime balancing rotates operation toward the least used sets. The values also appear on the local LCD, but they do not stay inside the controller. The same parameters are exposed as Modbus TCP registers for a remote Modbus master. Here, the W55500-based Ethernet module does not decide how many lights should run. It provides the Modbus TCP path that makes sensor values, operating levels, and runtime data available to another system. In the first project, Ethernet exposes industrial state. In the second, it gives a homeowner local control over an existing energy system. The heat pump was already installed. OpenQuatt gave its owner a local view and a local control surface. OpenQuatt is community-developed ESP home firmware for Quatt Hybrid single and duo systems. It adds a local web app for setup, monitoring, updates, backup, and management. Home Assistant dashboards and automations are optional rather than required for the core installation. For the heat pump controller queue, the project provides separate Ethernet builds for single and duo configurations. Those builds use the controller's W5500 port. The heating strategy still belongs to OpenQuatt and the heat pump system. W5500 is the wired route to the local interface. This distinction matters. OpenQuatt is community firmware provided on a best effort basis, and it is not the official Quatt support channel. What if an industrial controller could be programmed with the same syntax as an Arduino? The JWPLC platform packages the JWPLC basic controller for Arduino IDE and Arduino CLI. Its goal is to make industrial hardware feel familiar without forcing developers to initialize every peripheral manually. The platform brings together 8 industrial digital inputs, 8 relay outputs, a TFT display, buttons, RTC, FRAM, microSD, RS485, Modbus RTU, and W5500 Ethernet. High-level objects expose those peripherals directly to the sketch. Even the build system became part of the engineering work. In a documented cold build comparison, an alpha release reduced compilation from roughly 136 seconds to about 60 seconds, while retaining the integrated peripherals. The PLC sketch still owns the machine logic. The W5500 integration supplies DHCP, link state, reconnection, HTTP, and the Ethernet runtime. One Ethernet lighting stream becomes 4 DMX universes. That is 2048 lighting channels. FM-ArtNetNode 4U version 2 was built as a student's final project. The creator designed the PCB, selected the components, developed the firmware, and produced the enclosure. A Raspberry Pi Pico receives ArtNet through a W5500 Lite Ethernet module. The firmware extracts DMX data and sends 4 universes through MAX 485 interfaces. The design also includes last frame memory, status indicators, and a web server for network and universe configuration. Here, the artistic cue comes from the lighting software or console. The Pico maps that data to DMX outputs. W5500 receives the ArtNet traffic. It does not choose the colors or design the show. The wake word can stay on the device. The heavier speech and language inference can stay on a local server. Willow's public project demonstrates a self-hosted voice assistant architecture with speech-to-text, text-to-speech, language model services, and other inference tasks running on a user-controlled server. On the ESP32S3 side, Espressif's WakeNet model packages provide on-device wake word detection. This 5th WIZnet maker curation asks how that endpoint could evolve with a wired Ethernet route. The roles must remain clear. WakeNet detects the wake word. The inference server handles the heavier language tasks. A W5500 path would only carry endpoint traffic across Ethernet. It would not detect speech or run the AI models. This is an architecture direction presented by the curation, not a claim that stable W5500 support is already an upstream Willow feature. 5 projects, 5 completely different applications, but the architecture repeats. In the disinfection controller, Ethernet exposes Modbus registers. In OpenQuatt, it provides local access to a heat pump controller. In JWPLC, it becomes part of an industrial development runtime. In FM-ArtNetNode, it brings ArtNet into 4 DMX universes. And in the Willow evolution concept, it could connect a local voice endpoint to self-hosted inference. The WIZnet device is not the application brain, it is the network boundary. That is why these projects are more interesting than a list of Ethernet specifications. Each one begins with a different real-world problem. The network becomes useful only when it disappears into the architecture and lets the application do its job. Which project should WIZnet TV unpack next? Industrial I/O, heat pumps, PLCs, lighting, or voice AI? Comment one word.